Hello. In this lesson, we're going to talk about transforming two-dimensional figures. We talked about symmetry and how uh, there were lines of symmetry, which were creases you could make in a shape to have two identical halves. It's where can you fold the shape. And this one, we're going to look at moving two-dimensional shapes around on a coordinate plane or enlarging or shrinking those shapes. So these are transformations of two-dimensional shapes. And these transformations come in different forms. There's different ones of them. So there is a reflection. That's when you flip it across a line. If you were to hold a mirror up to something, it reflects and it's backwards. So if you stare in the mirror and raise your left hand, it looks like your right hand in the mirror. The reflections are changed a little bit because they are reflected. And we can change where we reflect them at. We can change the placement of the mirror. And that's called the line of reflection. So wherever that mirror is sitting, that's your line of reflection. We also have rotation. Now that's when you take one point and rotate a figure around it. And we measure this in degrees. So it could be, and it can also be clockwise or counterclockwise. So there's a couple of things that we will list when we talk about rotation. First, you have to tell me the point, the rotation point, and the direction and the amount of degrees that I'm going to rotate a figure before I can do it. And we also have translation. So translations, that's when you slide a shape up or down on the coordinate plane. It doesn't change, it just moves. So if you lay a piece of paper out on your desk and you scoot it up and over, that's a transformation. So we have that reflection, that's when you're using a mirror. We have rotation, and we have translation. That's our third one, translation. We also have the last one that's called dilation, not 45. Dilations are when you are actually shrinking or enlarging an image. Remember when we asked if the images were similar? They're still similar. Side lengths are still equal ratios. We had a whole lesson about that. So you're going to keep this proportionality. It's going to make a similar image when you dilate something of either a larger or a smaller. And in dilations, we will use that scale factor again. If the scale factor is greater than 1, then it is an enlargement. Conditional statement there. If the scale factor is less than 1, then it is a reduction or shrinking. I'm going to make sure I got all my pieces of information in there. So let's look at some examples of all of this. Let's say that we have a square on this coordinate plane. And remember, although it doesn't quite look perfect, it's so much easier for me if I can make dots on here instead of lines. So there's, oh, that's not a very big line. Still not a very big line. Let's try this one. Oh, tried to make that smaller so it wasn't just a huge blob. Yes, you should be drawing this with me. Back that one up a little bit. Now, of course, I'm freehanding here, so it might not be the most perfect drawing. But let's look at the point of the vertices of this square. So we have point A, B, C, and D. We're going to first talk about a reflection. So if we're going to reflect this shape across the y-axis. So remember, our y-axis is the horizontal axis and the x-axis is the vertical one. So we are going to reflect this square across this axis. It's like we're going to put a mirror right here and take that image that we end up with and we're going to put it right here. So one surefire way to do that is to count your spots. So the first vertex is how many places from your reflection line. How many units out is that? That's 1 unit on the positive side. So when we reflect it, we're going to have 1 unit on the negative side. Now we've reflected that spot. I don't like that. Fine. Right there. So we reflected A across. It is now known as A prime because it's been reflected. So B is 1, 2, 3 units away from the y-axis. So if we look at point B is 3 units to the right. When we reflect it, point B is going to be 3 units to the left. It's just the opposite direction. So B prime is going to be right there. Again, it doesn't look exact because I'm having to freehand my dots and my graph, but if we had exact graph paper, it would be perfect, okay? So how far in the positive direction is vertex C? Well, it's 3 this way. So C prime is going to be 3 this way. We're not going to change the horizontal location of this. We're just reflecting it. So here's our C prime and our D prime. And there's a reflection. All you need to do now is connect the dots like so. Probably make yours a little straighter than mine. And that is a reflection across the y-axis. You can also reflect this across the x-axis. And if you did, we'll do this one in green. Go across y. And now we'll do a green one across the X. So same exact questions. When we reflect this, how far in the positive direction is A? We'll go the same distance in the negative direction. Same for B, C, and D. So A is 4 up, so A prime will be 4 down. B is 4 up, B prime will be 4 down. So there's A prime and B prime. Point C and D are 0 units away from X, so guess what? Point C prime and D prime are also 0 units away from X. And there's our reflected shape across the X-axis. And we also have up here, the green one is C prime. Oops, excuse me, that's not C, that's D prime and C prime. And there you go. So there's your reflection. Now another reflection that you're going to see is across a line. We're going to go back to our graphing. What if you were going to reflect this across the line X equals 7? First, you have to find the line. And if you're going to reflect it across this line, X equals 7, it's the exact same principle. How far in the positive direction or the negative direction do you need to go? So for B, how far this way are you? Well, B prime, you'd go that same distance this way. So you're going to end up with a green rectangle, the same distance on the other side, and it's going to be the exact same size. If you reflected it across X equals 7. Half the challenge in your reflections is figuring out what graph they're talking about. Many times, you are going to have to reflect across the Y equals X line. So let's look at that Y equals X. What's your slope and your y-intercept? Well, that's y equals 1x plus 0. You need to remember that from algebra. So your y-intercept is 0, 0. And you're going to go up 1 over 1, up 1 over 1. So the y equals x line is right there. You need to know what line that is. Y equals x. Whoops, excuse me. That's y equals negative x. Now, if you're going to reflect something across the y equals negative x line, you're going to count the distance up and over from the line. So A prime would be up 3 and over, no, just a straight up 3. So from the point on the line, you would go down 3. So it's kind of like we're going to turn this around that line because it's sitting on it. And then if we were going to reflect B, B wouldn't change, it would still be there. C would be way up here, way high. And then D would be right here. Whoops, the daisy. D would be up here. So if you reflected that around that y equals x line, you would pretty much be twisting it. It is the same concept as reflecting across a vertical or a horizontal line. Count the spaces up and over and put in your prime vertices. Okay? All right. Rotation. Let's talk about rotation. A rotation of 180 degrees. How much is 180 degrees? So the key in rotations is you remember a circle. Here's our circle. How many total degrees are in it? 360. Halfway. So we're going to start right here. And we're going to go halfway around the circle. That right there is 180. Either way, counterclockwise or clockwise. If it's that far, it's 180. Well, what's half of that? So let's say we're going to go from here to here. That is a tricky one. So it's either 90 degrees or it can also be 270 degrees. It depends on if you're going clockwise or counterclockwise. So if we're going clockwise from 0, it was 90. But if we're going counterclockwise, it was 270. And then, of course, in between each quarter of the circle, each eighth of the circle, is another 45 degrees. So you can figure that one out. So this would be 315 because it's 45 away from 360, or it would be 45 if you're going clockwise. So 45 and 315 are at the same place on this circle, depending on which direction you go and where you start from. So if we take a rotation, and I'm going to scoot some of this way up here because I need some room for rotation. I'm going to move the translations up because we're going to get to that in a minute, and we're going to move up dilation. So on rotation, when you're rotating about a certain point, every vertex needs to rotate that same amount. So you're going to actually put a circle on something and look at the degrees in that circle. All right, let me see if I can. It's gonna have to do a new one. I need a bigger graph with my problem here. There's that. All right, now let's put some dots on here. I'm gonna do my best. Keep those exact because I want this picture to turn out as accurate as possible. This is no different than the lines that we typically put on our coordinate plane. It's just so much easier for me to make a dot. All right, now let's get a shape on there. We're gonna have shape JKL, and we're gonna rotate JKL. There's 3 vertices on JKL, so it's a triangle because it has 3 corners. So we've got point J is located at 7, 5. Excuse me, -7, 5. So point J is right here. Point L is at negative 7, 2. Point K is at negative 1, 5 as well. So here's point K. Yep, got it. Let's connect those dots. There is our triangle, JKL. And what we're going to do is we're going to rotate JKL 180 degrees clockwise around or about the origin. We're going to rotate triangle JKL 180 degrees about the origin. Okay? So we're going to have to take all three of these points and we're going to have to move them 180 degrees around this point, the origin. That's our rotation point. We need a circle. We need a circle to accurately measure 180 degrees. So we're going to draw a circle, and point L is going to be on the outside of that circle, and I want to try to get perfect of a circle as possible. And I need this circle to be centered at the origin. See how I'm not in the middle? Gotta be centered because that's my rotation point. I need this circle to be centered the other way as well. So that's a pretty centered circle right there. And I'm going right through point L. Now I need to connect point L, a diameter, containing it to the other side, because how much is that? That is 180 degrees. So if I go all the way around clockwise 180 degrees, that is exactly where my new point's going to be. And I should probably get some labels on this. So this was actually J, K, and L. So my new L prime is going to go 180 degrees around this circle, and it's going to end up being right here. There's point L prime. That's the one that I moved. That's L prime. All right, I have to move all three of these points 180 degrees around this circle. So I need to center a circle centered at my rotation point. So to do a rotation, you need a circle that is centered on your rotation point, and your point, your vertex, must be on the circle. So I need a circle that contains point J centered at the origin. I'm going to have to make this circle bigger, aren't I? So this circle needs to grow until it reaches point J, but still is centered on the origin. I may not be able to get that one all the way down there. So we're probably just going to have to estimate that one. If your circle doesn't work out exactly, what else could you do? You could see how far between J and L, what that distance is, and you could put this in over here. As you can see, my screen is not big enough. So what I can do on this one is I could say, well, if I were to go all the way across the circle through the center, J would end up being below L, wouldn't it? J prime is below L prime because we're rotating this around that way. Okay? So how far above L is J over here? Well, point L was at -7, +2. Point J is at -7, +5. So there's 3 in between there. We know that that side is 3 units. So we could make our spot over here 3 units below. We can use what we know about reflection. That's probably a little bit. That's where it should be. And that's going to be J prime. Okay, now let's figure out K prime. Let's see if my screen is going to allow me to make a circle centered at the rotation point, which is the origin, and containing K. Not a bad circle, is it? Not a bad circle at all. It's a little too high. There we go. All right. Now let's do the exact same thing. Let's draw our diameter because we know the diameter is half the circle, so we know it's 180 degrees. Let's draw a diameter from K to the opposite side of the circle and make sure we're on the circle. There's my 180 degrees. Therefore, I know K prime, if I'm rotating 180 degrees, is going to be right there. Now it's a matter of connecting these dots. And we should get a pretty, clearly my circle is not perfect. Hold on. My circle is a little bit too tall. If you had yourself a perfect circle, it would be a lot easier. This one does not stay proportional. There we go. All right. So we start at that, we go right through the middle. And this is now we've got it. There is our K prime. So the hard part of rotation is knowing how many degrees you need to go. But if you will just get a circle, you can also use a compass. On your virtual tools, they're difficult because you don't have any of those. We're going from just visual on that one. So you can, in your mind, imagine that you took that point K all the way around the circle. No, we're waiting on your dad. And that's the way it ended up. So when you rotate 180 degrees, every single point is going to follow a circle all the way around, so it should end up directly across from itself. So look, 180 degrees is directly across, directly across. Take your circle, make a perfect one, and center it on your rotation point, and make sure your vertex is on the circle. It's easy to find your degrees when using a circle because you know 180, 90, 45. And then you just need to remember which way a clock goes. Okay, so there's some rotations. Rotations are very much about spatial and visual imagination. So if that's a weakness for you, rotations are difficult. Use the circle tool. That will help you. Find something in your house that's perfectly round, a bottle of water, a lid off of a bottle of water, something that's a perfect circle, and you'll be able to use that. You just have to get one the right size. Okay? You can also use one of those compasses. They look like this for those of you that can't remember what a compass looks like. It's one of those things, and it has numbers on it. Yep. So what you want is your center point. For this example would be the origin. This is where you're rotating from. That's your rotation point. Then you have to line this up so your vertex would be lined up here. You'd have to extend it. So here's your vertex. And then you'd have to extend a line 180, and then you'd know, oh, okay, that's where my next one ends up. So it's a little difficult with a compass unless your compass is big enough to reach your point. So even that way it's difficult. You'll have to get a ruler out. Okay, let's talk about translations because they're really the easiest form of transformation. It's something I wanted to keep. There we go. All right, so a translation is when you slide a shape up or down on the coordinate plane. They're the easiest one, and you can figure out the rules for these, and you're going to have questions to ask you to do that. So let me just put a shape on here. And then we'll look at the pink one. Now, if given this is the original, and this is the transformed, what is the rule of transformation? The translation rule. Anybody can take that shape and move it down and to the right when it tells you how many to do it. We're going to skip that part and we're going to look at this a different way and we're going to figure out, how much did it move? Actually, these are exactly the same. And I want them to be exactly the same. There we go. Cheated a little bit on that, didn't I? There's a good one. Okay, so let's put us some markings on here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 4, 5, 6, 7. 1, 2, 3. Now, we need to know how far over and down it went. So we've got A, B, C, and D. Well, in the other shape, we have A prime. Now remember, all you can do is scoot. You can't just slides across the coordinate plane. You can't flip it, rotate it, reflect it, shrink it, enlarge it, nothing. These translations are the easiest ones to study. So for A to get to A prime, what happened? When you're stating the rule, you're asking yourself, how did it get there? How far over did it go? And how far down from A to A prime? What happened? It's kind of like counting the slope. 1, 2, 3, 4, 5, 6, 7, 8. So it went positive 8. So we'll say 8 units to the right. And then how far down did it go? 1, 2, 3, 4, 5, 6. So it was a negative 6. And you would say 6 units down. So on these translations, you're going to be told the rule and asked to graph the new shape, or you will get the two shapes in a picture, and you will be asked to come up with the rule. Okay? All right. The last one that we're going to cover is a dilation. Dilations, that's when we shrink it or we make it bigger. What if we had this coordinate plane? Let me go ahead and get some markings on there. So we'll have our original figure. Let's say our original figure is there. So our original figure is 3 by 3. And then we're going to have two other figures. So there's one of them. This is A, B, C, D prime. This is A, B, C, D. And then we have another figure. This. And this figure is A, B, C, D prime prime. That's our second one. So these are both dilations. So ABCD is the original one. ABCD is a dilation, which happens to be an enlargement because it got bigger. ABCD prime prime is a reduction or a shrinkage because it got smaller. So what we want to do is figure out what is the scale factor. By how much is it shrinking? So we could count the units. So ABCD is 6 by 6. What was the factor? What was the factor that we multiplied by to get these? Remember, they always have to be the same ratio. They have to be increasing or decreasing in proportion. And that one has a scale factor of 2 because you multiplied by 2. So on your dilations, you'll either be given some measurement or you'll be given a scale factor, and you'll have to either graph the new one using the distance formula probably, or you'll have to count and say, oh, okay, I see, it's half. So that would be a scale factor of 1/2. All right, now let's look here. Let's look at the other one, the little one. So it's 1 by 1, and that would be given to you. Or you could count it if I could draw the graph exactly, but it's 1 by 1. So look at the original and now look at the transdilated figure. Both of those we do what? How do we get from 3 to 1? The scale factor was dividing by 3. You have to put that as a number. So the scale factor, it shrunk, so it's less than 1. If it enlarges, it's greater than 1. If it shrinks, it's less than 1. Something less than 1 is a fraction, yes? So the scale factor is 1/3. We divide it by 3, so it's 1/3. And that's your dilation. There's a lot in this lesson. There is a whole lot, and I know that. They all kind of go together. Remember, you're going to upload pictures of your handwritten notes. You should have a lot of notes for this one. You're going to show all of your work. There's going to be some algebra, some math, some pictures, all of that. So you're going to draw the pictures, you're going to do the math, you're going to write out the steps, all of it. You should have a lot of notes for this one. You're going to use homework help for anything that doesn't make sense. You want to make sure you understand this completely, get some extra instruction on your own. And last but not least, your multiple choice answers are going to go into the Google form. And I will tell you, number 1, on this one, answer any of them. Number 1 is blank on this one for a reason. So you're going to answer any of those answers and it's going to be correct. All answers on number 1 are correct. Okay? All right. I'll talk to you in the next lesson.